SwayamPrabha. Digital India. Educated India.
So, welcome you all for lecture 3 of module 2. This time we are going to cover the defects of wood and wood joinery. So, in the previous lectures we have understood wood and how to get it from the tree, what we all know. So, after getting it we need to use it for our purpose. So, as a building material we need to know it, how to use the wood. But prior to knowing that, we need to know what are the defects that can happen or that can appear in these wood or timber which we get for this purpose. So, coming to the defects here, apart from knowing these defects, we will also go to the different types of joints and I will give you a brief introduction of engineered wood. Through conversion, we have come for the different types of wood, and during conversion if you are careful of the defects, if you can avoid the defects, then you will get good quality wood. So, procuring wood of good quality needs to be done after identifying the defects. So, we as architects also need to know when we look for a good wood, we should be able to understand if that wood contains any defect or not, because we may recommend it for some structural purpose or it may be framing a window or a door or a wooden truss. So, we must be knowing how to identify the defects. So, let us come to that. First defect is shake. Different kinds of cracks that develop due to loss of moisture and the oily substances which are very natural, which are naturally produced inside the timber, gets lost due to maturity or over maturity. Such defects should be avoided when we are converting the wood. As we have talked of the different types of conversion, in some cases we may be able to avoid such, and in some cases we keep the defects along with it and we get inferior strength of the wood. So, first are the shakes, where you see that there are different types of shakes: heart shake, star shake, radial shake, cup shake, upset shake. Let me try to show you a few shakes. So, when the shake within the cross section starts from the center or the pith and propagates outward, so these are fine cracks developing, and these are due to loss of adherence of one layer to the other. So, this kind of crack is called heart shake. So, from the heartwood it evolves and moves to outside. So, this is starting from inside and proceeding outside. Similarly, you can have star shakes the same way when this is coming from outside to inside. This may be because of loss of moisture from the outside surface. So, you can see the cracks are from the outside and moving inward. Then you may have radial shakes. Where along the annual ring you will find cracks are generating cracks are generating radially outward. So, for these all cases, actually if you go for radial conversion, you can maximize your good quality wood collect. You can see cup shake, the other one, which is again talking of shakes which are happening in between layers. So, if you have annual rings, you may have splits in between your two annual rings. So, these are, so you may have multiple such, and during the process of conversion you have to avoid such areas. These are weak areas, these are having loss of adherence of one layer with the other. Now, certain shakes happen due to injury. Say you cut down a branch of a tree. So, in that portion of that branch, actually what will happen, the fibers will try to bend and move out, move to grow. So, gradually what will happen, this portion from where some cutting had been done, there all the fibers have twisted. This may happen due to cutting of the branch. Also, this may happen when a particular branch or a particular trunk is subjected to wind. So, there is a lateral force which is allowing it to bend in one particular direction. So, that gives rise to twisted shakes. So, you can get the fibers twisted. What will happen? The strength will get lost and you cannot saw it, cutting will be very difficult. So, any ruptured part may lead to ruptured fibers which itself find their direction for growth, or it is due to a continuous wind or continuous force in one particular direction, allowing the group of fibers which are the xylins, which are the carriers of the water and the salt, they have moved with time in one particular direction. That has created the fibers in a different direction, they are no longer perpendicular to the rest of the fibers. So, these areas become weak portions and these all are together called shakes. So, shakes can be because of loss of adherence, or because of injury, or because of continuous force of storm or wind in a particular direction, and the behavior of the fibers or the pattern of the fibers get deformed. After these, we come to some more defects. You see knots and wrinkles, twisted fiber, wind cracks. So, knots are the areas where from the branch has been chopped off. So, the fibers have moved and some fibers have got cut. So, again a set of fibers has grown beyond it. So, that portion locally the fibers may not have bent, but have got cut, and there actually the weakening has happened. Wrinkles are after cutting such kind of branches, or the branch has failed because of wind, there a lump kind of growth happens. So, you can see on a particular portion of a tree there is a big growth or mass. So, these also try to disturb the fiber movement, and that actually weakens this portion. So, these wrinkles, knots can be very well identified. Here sometimes the cells get dead prior to maturity of the tree. So, these portions are weak portions. So, the basic message is, in a branch, in a piece of log, you can identify these by looking into it. You may find in a piece of wood, you can find a knot there and the fibers are moving just like this. So, you can see a dark patch here which is the dead cell. So, by looking at the grain structure and the pattern, you can identify whether there was a knot which is a dead part, and that is the portion which needs to be avoided when we are proposing the use of this particular timber for a structural member. Twisted fiber, as I have already told, it is a again kind of shake, but because of twisting it is called twisted fiber. Wind cracks, due to facing wind, particular direction of a tree trunk which is subjected to wind may get multiple cracks, dried up. So, these are called wind cracks. Again, weakening in strength, particularly the tensile strength, is to be noted. We have another two types of defect. Those are called rots. One is dry rot, the other is wet rot. When the decomposition of the wood brings in, when you touch, it becomes powder like. It is a brown powder which comes out. On touching, it breaks and becomes a brown powder. This is not due to age of the tree, but it is due to fungal attack, and this usually happens inside. Whereas wet rot, it is happening mostly on the outside surface due to wet condition, that is damp and humidity has helped in the formation of these fungal growths, and that has led to rotten portions on the tree surface. So, these are wet rots. So, once you understand this, whenever you see a timber piece, you can, from the grain alignment, you can understand what was the cross section like, what kind of conversion have happened. From the features on top of on the grain side, you can understand what kind of rots, what kind of shakes, what kind of knots are visible, and this can give you a clue on the quality of the wood. Now, when we need wood for the building purpose, we may require in it 2 feet length, we can require in it 12 feet length. When it is subjected to tension, when it is subjected to axial load, we may have a roof truss, it may have wooden members as long as 14 feet, 15 feet. Again, we have a furniture where a person, if we need a chair where I need to sit, it has to take the human load, one human load. With its 1 feet, 1.5 feet height foot, the support. So, there it is experiencing compression. So, these small pieces need to get assembled to form a chair. At the same time, you can get small pieces for the chair by cutting, but if you need a 12 feet member, you may not get in a continuous length of wood, you need to join it. Now, how to join it with minimum loss of strength? Because already we have talked, the weak portions are to be taken out. So, you may eventually need 2-3 joints to make a long piece. So, this brings in the process of joinery, which is woodworking that involves joining together pieces of wood or similar kind, means wood or wood equivalent, to produce more complex items. If you can get one long piece, very fortunate you are, but usually you cannot get such long pieces. Now you have to join two pieces together, maybe in right angle, maybe in an oblique direction. So you may require to join two pieces or two members in right angle. Say in case of a chair, you may have to have your framing in such a way. So you have these as taking the load in the tension, these as taking the load in the compression. So this forms your main structure. Similarly, you may have a wooden truss to be made, where you may need to make supports in oblique direction. So here you need to have joints with one member with the other in oblique direction. You may further strengthen the joint by use of adhesives, fasteners, binders, nuts and bolts. So you can loosen it and take it out. You can refix it. If you eventually have a rotten wooden member, you can replace it. So this joinery has a beautiful way of adding wood one after the other to make a complex item of it, and you can replace individual members if required. Now you have to remember some points when you are doing this wood joinery. You remember the xylems and phloems flowing. So they are in whichever direction they are, in the vertical or in the horizontal. When it is tension member, they should be in the horizontal direction. Whenever they are subjected to compression, the xylems and phloems should be in the vertical direction. So they ensure the strength of the member. So some joineries may be helped to lengthen members, some may be required to widen members, and some joinery may be for bearing loads. What do I mean by widening? You need a tabletop. You are adding one member with the other in such a way that it gradually forms a surface which can become your tabletop. Lengthening member, when you have a beam, its small piece joined together, you get a big beam spanning between two ends, maybe walls or maybe two other wooden members, which is where you need lengthening, and load bearing is where you are subjecting it to load. So let us move to the lengthening joints. Now here you see they help to extend members to desired length, like beams, truss members. Lap joint is the simplest one. So one member, a portion of one member is taken out, and on top of it the other member is sitting, as you can see in this drawing here. So to maintain the thickness, continuity, half of one member has been taken out and half of other member has been taken out, and the opposite direction they are placed and they form together one member. Now who is holding it? Either you have to put a nut or bolt, or you have to strap it by a metal plate. Otherwise they can separate out. See the little more complex picture where a beveled cut has been given. So a little more slanting. So here the grip is further better, but even they can move apart. Look at the third one, which is the tabled joint, where you see they can displace in this direction, they can move out, but they are sitting holding each other. So, here you may not strap it or you may not nail it, it will remain in its position, but even then you need to strengthen it or to strap it. So, this is called table joint. They can take both tension as well as compression and they help in joining. Now, you may require to cross one member while it is because it is a long thing, you can see in these portions of this picture. Here these are not sitting on it, but they are going to get inserted inside it to a small length. So, whatever will be the requirement, based on that you can have cross half lap joint. You can see here this detail. Let us move to the widening joints. You need to make a flooring. You all have drawing boards. If you see the edge, you will see planks joined one after the other. Butt joint is the simplest, where no cutting is involved. One sits beside other and they may be held by means of nails, just by nailing. So, this can happen only when the surface is supported by some supporting member at the ends. If you have a support here and here, you can keep on placing members one after the other. If you have another support here and here, so you can place wooden pieces or planks one after the other and you can create a surface or you can widen the joint. So, here there is no basic joinery involved. This can happen when you have a connector to a river bridge. Planks are supported on steel members, one after the other inside a groove, so they never move out and it creates a surface for people to walk. Let us see another kind of butt joint, which is called biscuit joint. What has happened? Two members are placed side by side, but in each of them grooves are made and is connected by a supporting piece, wooden piece, which holds the two pieces together in position. They reinforce the joint. This is called biscuit joint and it adds strength to the joint. They usually do not slide, you cannot take out one from the other, you cannot separate them. Adhesives may be applied to further fix it in position. You have tongue and groove joint. You can watch this, you can see this in your drawing boards. If you look at the cross section of the drawing board, you may see something like this. Then one member sits again. So, this projection continues to form the board. So, this portion projection is called the tongue and this is the groove inside which one gets into the other and you get an uniform sheet, uniform flat surface, that is what is called widening joint. So, you can get continuous surface by putting one after the other through tongue and groove joint. Now, we come to some more joints, which is again metered butt joint, which is a bevel joint, half lap joint. Depending on the structural system, the angle of the joints may be oblique, they may be at 45 degrees. nuts, bolts, straps, mechanical fasteners, adhesives are added to strengthen joints. Let us see some more type of joint, that is the bearing joint. Bearing joint, we try to minimize the loss of strength. So, they are usually provided at junctions, mostly at right angles, and are capable of taking load. Tenon and mortise joint is one such. Dovetail is another joint. Housing one inside the other is called housed joint. So, one member may be very heavy, into it a new member sits inside, that is called housed joint. We have bird mouth joint, notched joint, haft joint. So, there are several, but what is more to be put into mind is that bearing joints, the weakening of the joint cannot be allowed. So, let us see some bearing joints. The tenon and mortise, you can see the tenon is a projection, whereas mortise is a chase. Chase means a cutout. And if you see this picture, you can see that a third of it, one third of it has been retained, one third of it has been retained on this side, and one third of it has been used for the chase. So, this tenon is also similarly made with the extra piece of wood, and that can go and sit together to form the tenon mortise joint. Now, this can happen in right angles, as you can see. This is kind of open mortise tenon joint, this is corner joint, but the principle remains the same. It is open tenon and mortise joint. Now, we see dovetail joint. Here you see, instead of the tenon, which was uniform or perpendicular or the edges were perpendicular, here you see the projection has fanned out. It has come out like this, splayed. Similarly, the receiving part has also got splayed to receive the tenon, the projection. So, this mortise is made wider to form a tail like projection, and hence it is called dovetail. This joint is more rigid considering tenon and mortise. In tenon and mortise you can pull it out, but in dovetail you cannot pull it out because it is wider at the end and smaller at the point from which it has to come out. So, you have to entirely open the assemblage to get it out. We have housed joint, as I told you, one portion which is a structural member. So, if I draw it like this, so this housed joint, say this is a member cross section which is quite heavy piece, will have the notch or the groove which will go inside up to a given distance, and the member which will come out of it will totally be housed inside it. So, this member is no way getting weak. So, this member actually sits inside this groove. So, what has eventually happened? This member is not having any weakened point. So, in that case, this member has to be sufficiently deep and wide. So, this is called housed joint. These are some more joints which you can use for wood as well as I told you wood like. We will come to engineered wood just after this lecture. So, we see box joints or finger joints. You see so many projections are there, and these projections have just complementary receiving members, receiving grooves. When they are set together, it forms a joint. So, this is the simplest box joint, and then again you can have dovetail on it. So, corresponding cuts to be made. These can be nowadays machine made. You see here the joint has formed. Similarly, you can see half blind dovetail. So, a portion of it has been retained to give a neat finish to the outside surface. So, this surface you see there is no joint, but at the same time it is supporting something. So, that means you can actually make beautiful finishes, neat finishes without showing the joint. You can even create such kind of joinery. These are called half blind dovetail joints. Again, as the biscuit joint you have seen, you can also use dowels, which will be totally part of it will go in one member and part of it will go and sit into the other member. So, these dowels can strengthen the entire joint. Whatever the kind of joint it is, you can insert dowels and actually make it a very strong joint. So, these dowels can even be metal. So, how can we conclude the chapter of wood? Wood is obtained from naturally growing trees and may have defects due to various causes. Defects are to be avoided before putting it to use. Joinery helps in connecting two or more members and creating a usable item. It should be remembered that joints should be made along the fiber and not across the fiber. Before moving to the next lecture, I would like to summarize that wood is a naturally occurring material. We can use wood, but at the same time we also need to look into what are the alternative or engineered wood which we can use from the wood and what are the good points of it in place of using wood. As you understood that during the process of conversion, even there are losses up to 40% of wood. What happens to that unused wood? Does it go waste? Does it get burnt and become fuel? Can we not use it for our purpose? What happens if the defects can be avoided by engineering the wood? So, next lecture we will go for engineered wood and we will try to see how the defects or the problems which we have encountered by using wood have been taken care, and we will see that nowadays actually we are using more of engineered wood rather than using more of wood. Thank you.